session, we will going to discuss the conversions. And by the way, I am Rochelle Darlo from BSHM 4B. Number system. The system used to count discrete units is called number system. So there are 4 systems of arithmetic which are used in digital electronics. So what are those 4? First is the binary number system. Second is the decimal number system. Third is the octal number system. And the last part is the hexadecimal system. Decimal number system. Decimal number system contains of 10 digits, which are the 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And that is why it is base or radix is 10. Here, radix means a total number of digits used in any system. To indicate digits greater than 9, we shall use the sum of these digits times power of 10. Fractional decimal system. The decimal system is composed of 10 numerical or symbols. The 10 symbols are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Using these symbols or digits of number, we can express any quantity. The decimal system also called base 10 because it has a 10 digits. For example, is that 10 to the power of 4, 10 to the power of 3, 10 to the power of 2, 10 to the power of 1, and 10 to the power of 0. And the other side was 10 to the power of negative 1, 10 to the power of negative 2, 10 to the power of negative 3, and so on and so forth. Decimal number system. The decimal number system is positional number system. For example, number 1, 5, 6 to 1. 5 should be 10 to the power of 3, 6 is 10 to the power of 2, 2 is 10 to the power of 1, and 1, 10 to the power of 0. Sa computation naman niya is 1 times 10 to the power of 0 is equals to 1. Siya yung tinatawag na unit position. 2 times 10 to the power of 1 is equals to 20. Siya ang tens position. Then 6 times 10 to the power of 2 is equals to 600. We can call it hundreds position. Then 5 times 10 to the power of 3 is equals to 5,000. Siya yung thousands position. For example, number 2. We have here a 4137. 4 is 10 to the power of 3, 1 is 10 to the power of 2, 3 is 10 to the power of 1, and 7 is 10 to the power of 0. So we can compute this as 7 times 10 to the power of 0 is equals to 7. Every time na ta-times tayo sa power na 0, kung ano yung t-times yun doon, yun din yung magiging sagot. Yun yung unit position. 3 times 10 to the power of 1 is 30. Tens position. 1 is times 10 to the second power is 100 or hundreds position. Then 4 times 10 to the third power is equals to 4,000 or the thousands position. Para naman sa binary number system, the binary number system is also a positional numbering system. Instead of using a 10 digits yung 0 to 9, the binary system uses only 2 digits which are the 0 and 1. The binary number system is also known as base 2. The value of a positions are calculated by taking 2 to some power. Why is it base 2 for binary number? Because we use 2 digits. The digits are the 0 and the 1. Octal number system, also known as the base 8 system, uses a digits of 0 to 7. Readily convert to binary. Groups of 3 binary digits can be used to represent each octal digit. Also uses multiplication and division for conversion to the form of base 10. In digital system, the information that is being processed is usually represented as binary form. Binary quantities can be represented by any devices that has only 2 operating states or possible condition. A switch has only open and close. We arbitrary as we define them. Let an open switch represents the binary 0 and the closed represents the binary 1. Thus, we can represent any binary numbers by using series of switches. And here is the example of binary number system. Example number 1, binary number system. Fractional binary system. In the binary system, there are two symbols or possible digit values, 0 and 1. This base 2 system can be used to represent any quantity that can be represented in decimal or other number system. For example, this is the example. 2 to the power of 4, 2 to the power of 3, 2 to the power of 2, 2 to the power of 1, 2 to the power of 0, and the other side was 2 to the power of negative 1, 2 to the power of negative 2, and so on and so forth. The binary was below, 10101. On the right side, we have LSB, least significant bit. On the left side, we have MSB, which is the most significant bit. And for the hexadecimal number system, hexadecimal is based by 16, uses digits 0 to 9 and the letters from A to F. Groups of 4 bits represent each base 16 digits. Fractional octal number system. The octal number system has a base of 8, meaning that it has 8 possible digits, which are the 0, 1, 2, 3, 4, 5, 6, and 7. We represent the octal number by 8 to the power of 4, 8 to the power of 3, 8 to the power of 2, 8 to the power of 1, and 8 to the power of 0, 8 to the power of negative 1, 8 to the power of negative 2, 8 to the power of negative 3, and so on and so forth. Used to represent a long binary numbers in computers and microprocessors. Octal to decimal conversion technique, multiply each bit by 8, where n is the weight of the bit. The weight is the position of the bit starting from 0 on the right. Add the results. For example, 724 subscript 8. For example, 724 subscript 8. 4 times 8 to the power of 0 is equals to 4. 2 times 8 to the power of 1 is equals to 16. 7 times 8 to the power of 2 is equals to 448. Then add all the answers is equals to 468 subscript by 10 or base by 10 because octal. Octal to decimal conversion. Another example, 2754 subscript 8. 2 times 8 to the power of 3 is equals to 1024. 7 times 8 to the power of 2 is equals to 448. 5 times 8 to the power of 1 is equals to 40. And 4 times 8 to the power of 0 is equals to 4. Add all the answers. It is equal to 1516 subscript 10. And for the last example of octal to decimal conversion, 0.3270 subscript 8. 3 times 8 to the power of negative 1 is equals to 0.375. 2 times 8 to the power of negative 2 is equals to 0.3125. 7 times 8 to the power of negative 3 is equals to 0.013671875. 0 times 8 to the power of negative 4 is equals to 0. Then the answer will be 0.419921.875 subscript 10. Octal to hexadecimal conversion. Let's convert 56 subscript 8 into hexadecimal. Step 1. Convert 56 subscript 8 into binary. In order to convert the octal number into binary, we need to express every octal value using 3 binary bits. Binary equivalent of 5 is 101 subscript 2. Binary equivalent of 6 is 110 subscript 2. Therefore, equal 56 subscript 8 is the binary 101110. Step 2. Convert 101110 subscript 2 into hexadecimal. In order to convert the binary number into hexadecimal, we need to group every 4 binary bits and calculate the value. We start to write from left. So, 101110 subscript 2, hahatiin natin siya sa 4 binary bits. And calculate the value. So, 10 separate 1110. Yun yung magiging hatian niya. So, the answer will be 2 and 14. Therefore, pag tinignan natin siya sa table ng binary to hexadecimal, ang 2 ay 2, then ang 14 is equivalent niya sa hexadecimal is E. Therefore, the answer is 2E subscript 16. Octal to hexadecimal conversion, let's convert 56 subscript 8 into hexadecimal. Step 1. Convert 56 subscript 8 into binary. In order to convert the octal number into binary, we need to express every octal value using 3 binary bits. Binary equivalent of 5 is 101 subscript 2. Binary equivalent of 6 is 110 subscript 2. Therefore, equal 56 subscript 8 is the binary 101110. Step 2. Convert 101110 subscript 2 into hexadecimal. In order to convert the binary number into hexadecimal, we need to group every 4 binary bits and calculate the value. We start to write from left. So, 101110 subscript 2, hahatiin natin siya sa 4 binary bits. And calculate the value. So, 10 separate 1110. Yun yung magiging hatian niya. So, the answer will be 2 and 14. Therefore, pag tinignan natin siya sa table ng binary to hexadecimal, ang 2 ay 2, then ang 14 is equivalent niya sa hexadecimal is E. Therefore, the answer is 2E subscript 16.
Binary numbering scale. So from this table, base 2 number 0 and 1, sa base 10 equivalent start from 0 to 7. So the power also start from 0 to 7. Positional value is 1, 2, 4, 8, 16, 32, 64, and 128. Significant digits, so binary. Here's some example of the binary. So 11101101. So most significant digit is from the left side, and yung right side is yung least significant digit. So ganun din sa hexadecimal. Example is 1D63A7. So most significant is from the left side, and yung least significant digit is from the right side. So converting from decimal to binary, make a list of the binary placed values up to the number being converted. Perform successive division by 2, placing the remainder of 0 and 1 in each of the position from right to left. Continue until the quotient is 0. So example is 42 subscript 10. So mag-start tayo dito sa right side. So 2 to the power of 0, 2 to the power of 1 hanggang sa 5. So 2 to the power of 0 is equal to 0, pero magiging given na yung 1. Next is 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. 2 to the power of 4 is 16. And 2 to the power of 5 is 32. So magiging binary niya is from right to 0, 1, 0, 1, 0, 1. Next. Decimal to binary conversion. There are two methods to convert it. Revise of binary to digital method. Decimal number write as the sum of square 0 and 1 is write on the byte. Example 1. Convert 45 subscript 10 to the binary value. So solve is equal to 45 subscript 10 equals, so 32, 8, 4, and 1. So ulitin lang natin yung kanina. So from start tayo sa right side, gagawa tayo ng 2 to the power of 0, to the power of 1, to the power of 2, to the power of 3, and to the power of 5. Pero yung to the power of 1, hindi natin gagawin natin 0, tsaka yung to the power of 4. Kasi hindi siya kasama dito sa pinag-plus-plus na sagot. Sa 32 plus 8 plus 4 plus 1. So, tas yung magiging binary niya is, so 2 to the power of 0 is 0, pero given na nga yung 1. So, 1 yung sagot doon. Tapos yung 0, ibababa lang natin. So, bring down 0. Tapos, 2 to the power of 2 is isa lang. Isa lang kasi makukuha niya sa 2. Tapos, is 2 to the power of 3, isa lang din kasi isa lang yung 2 na pwede makuha sa 3. Tapos, yung 2 to the power of 4 magiging 0 kasi hindi siya kasama sa bilang. And then 2 to the power of 5 is isa. So ayan yung binary. So repeat division method. The numbers is divided by 2. The balance for the question is written until the last answer. Example, convert 25 subscript 10 to binary. So solve equals to 25 subscript 10. So, solve natin. So, 25 divided by 2. So, ilan bang to makukuha sa 25? So, 12. May balance na reminder or may balance na 1. Kaya, meron dun isa. So, yung 12, i-bring down natin. Gagawin natin yung 12 divided by 2. So, ilan makukuha to sa 12? So, 6. And then, so, 6. 6 divided by 2 is, tatlo lang makukuha to dun. So, walang balance or walang reminder. So, bring down 3. 3 divided by 2 equals, so, isa lang yung makukuha natin sa 3 na 2. So, may balance siyang isa. Tapos, yung 1 divided by 2 equals 0, pero magiging given. So, gaging 1. Tapos, ang pagkuha ng binary is from list to most. So 1, 1, 0, 0, and 1 subscript 2. So decimal to binary conversion, the easiest way to convert a decimal number is to its binary equivalent is to the use of division algorithm. This method repeatedly divides a decimal number by 2 and records the quotient and remainder. The remainder digits, a sequence of zeros and ones, form the binary equivalent is the least significant to most significant digit sequence. So, division algorithm, so convert 67 to its binary equivalent. So, 67 subscript 10 equals 2x subscript 2. So, dito na yung pinakang step by step niya. So, step 1, 67 divided by 2. So, equals 33 kasi 33 lang na 2 ang makukuha sa 67. So, may reminder na 1. So, step 2, 33 divided by 2 equals 16. May reminder 1 ulit kasi 30 ano lang yung makukuha natin doon. 32 lang yung sa 2. Tapos step 3, 16 divided by 2 is 8 lang na makukuha natin sa 16 na 2. So, wala siyang reminder kasi sakto siya. Tapos, i-repeat lang natin na repeat hanggang sa maging 0. Stop na tayo sa quotient pag naging 0 na. So, magiging binary niya is from top to bottom. So, hindi. From bottom to top. So, 0, 1, 1, 0, 0, 0, 1, 1, subscript 2. So, decimal to binary fraction. Example, convert the decimal number 12.0625 subscript 10 into binary number. So, solution. So, una mo natin kukunin is 12 dun sa may parenthesis. So, 12 divided by 2. So, ilan makukuha natin ito? 12, 6. Tapos, yung magiging ano naman is, wala tayong magiging reminder or balance kasi sakto. So, 6 divided by 2 is 3. Tapos, wala din makukuha ang balance kasi sakto siya. So, 3 divided by 2 is 1. So, isa lang makukuha natin sa 3. So, may balance na isa. And then, 2 1 divided by 2 is 0, pero gagawin natin 1 kasi given na siya. So, fraction part, 0.0625. Ito naman yung sa may, dito sa may, yun naman yung kukuha natin sa, dito sa kalapitan 12. So, 0.625 times 2 equals 0.1250. So, siya, wala. So, 0. So, walang sakto rin siya. So, 0.1250 times 2 is 0.2500. So, sakto rin siya. So, 0. 0.2500 x 2 equals 0.500. So, sakto rin siya. And 0.500 x 2 is equals to 1000. So, i-sakto. So, meron siyang reminder na 1. So, ang pagkuha naman ng sagot dito is, dun sa solution, ang pagkuha ng sagot is from bottom to top. So, 0, 0, 1, 1. Tapos, from the fraction part naman is from top to bottom. So, magiging is 0, 0, 0, 1. So, decimal to octal conversion. Convert from decimal to octal by using the repeated division method used for decimal to binary conversion. Divide the decimal number by 8. The first remainder is the LSB and the last is the MSB. So, example, convert 359 subscript 10 to decimal value. So, solve 359 subscript 10 equals to, so, okay. So, 359 divided by 8 is equals to 44. So, may balance sa 7 kasi ang kasya lang is 352 lang. So, yung 44, natin. Yun naman yung kakapatin natin. So, 44 divided by 8 is 5 lang kasi yun lang kayang makuha sa 44 na 8. So, i-bring down natin yung sagot na 5. So, 5 divided by 8 is 0, pero magiging given na yung 5 kasi hindi na siya kaya sa 8. So, ang magiging sagot is kukuha natin from bottom to top. So, 5, 4, 7. Or, mas madali is from most to least.
Hi, I am Kyla Cuyas, one of the member of this group. So, continuation lang tong i-report ko. So, decimal to octal conversion. Convert 427 subscript 10 to its octal equivalent. So, decimal to octal conversion, ang hinahanap natin is yung octal, yung base 8. So, nakalagay dito, convert 427 subscript 10 to its octal equivalent. So, 427, yung decimal, and yung octal is 8. 8 yung octal, diba? So, i-divide natin yung decimal sa octal. Yung decimal is 427, while yung octal is 8. So, 427 divide 8 is 53. So, may remainder, ilalagay natin yung remainder 3. So, kung ano yung answer sa 427 divide 8, ayun ulit yung i-divide natin sa 8. So, 53 divide 8 is equals to 6. Remainder 5. So, 6 divide 8 is equals to 0. Remainder 6. So, pag nag-0 na yung answer, is doon na mag-stop yung pag-divide. So, makukuha yung answer from the bottom to top. So, 6, 5, 3 yung answer. Huwag kakalimutang ilagay yung 8 kasi yun yung hinahanap. Bale, ayun yung octal base. So, yung meaning ng R is remainder or least significant digit. So, dito naman tayo kung paano makuha yung decimal to octal conversion ng fractional. So, example, convert the decimal number 225.225 subscript 10 into octal number. So, dun sa pag-divide, dito muna tayo sa divide. So, yung 8 is yung octal nga, and yung 225 is yung decimal number. So, di-divide lang ulit yan and continue hanggang mag-0 yung answer. So, makukuha natin yung answer from bottom to top. So, 341 or 341. So, dito na sa fractional. Ganun din. Ang gagawin lang naman is times. Ita-times naman natin sa 8. So, 0.225 times 8 is equals to 1.800. So, 0.800 times 8 is equal to 6,400. So, yun lang. Continue lang din. So, dito, pag fractional, makukuha yung answer from top naman to bottom. So, ang makukuha ang answer dito sa example is 16314. So, next, kung paano naman makuha yung decimal to hexadecimal conversion. So, sa examples, nakalagay, ang decimal is 315, while ang hexadecimal is 16. Diba? Hexadecimal is base 16. So, ang gagawin natin is, i-divide lang yon yung decimal to hexadecimal. So, 315 divide 16 is equals to 19. And then, yun lang. Continue lang ulit yung pag-divide hanggang mag-0 and then stop na. So, makukuha nga natin yung answer from bottom to top. So, another example. Convert 830 subscript 10 to its hexadecimal. So, 830 yung decimal, while yung hexadecimal is 16, is divide natin is equals to 51. Remainder 14. So, mababago yung 14 sa paglalagay ng pinakasagot kasi yung 14 doon sa table ng hexadecimal is letter E na siya. Hindi na natin siya ilalagay sa pinakang answer na 14 kasi letter E na siya. So, 14. Adi 51 yung answer. Divide 16 is equals to 3. Remainder 3. And 3 divide 16 is equal to 0. Remainder 3. So, from top to bottom nga makukuha yung, from bottom to top makukuha yung answer. So, 3, instead 14, ang ilalagay is E. So, 3, base 16. So, dito tayo sa decimal to hexadecimal fractional. So, di ba pag fractional times? So, kung ano yung i-convert mo is times to 16 lang. Kasi hexadecimal. So, kunwari, ito example, 225 convert into hexadecimal. So, 225 times 16 is equals to 3,600. So, 600 times 16 is equal to 9,600. So, makukuha yung answer from top to bottom. So, 3 and 9. So, ito yung explanation kung paano i-convert ang binary numbers sa decimal. So, yung bawat digit sa binary numbers is may position na kumakatawan sa power of 2. Mula kanan hanggang kaliwa, ang mga position is may katumbas na power of 2. So, sa bawat 1 sa binary numbers, pwede mo siyang i-times sa 2. So, sa bawat 0 naman sa binary numbers, kahit sang 2 mo siya i-times, is magiging 0 pa din yung sagot. Binary to decimal conversion, the easiest method for converting a binary numbers to its decimal equivalent is to use the multiplication algorithm. Multiply the binary digits by increasing power of 2 starting from the right. Then, to find the decimal number equivalent, sum those product. So, ito yung multiplication algorithm. Convert 10101101 to its decimal equivalent. So, binary is 1010110. Yung position value is 2 power of 7, 2 power of 6, hanggang sa mag 2 power of 0. So, yung product is kung ano na yung answer dun sa binary and position values na pinag-times mo. Pag 1 times 2 power of 7 is equals to 128. So, 0 times power of 6 is equals to 0. Gaya nga ng sabi ko kanina, kung kahit saan mong 2 i-times yung 0, is 0 pa din yung answer. So, 1 times 2 power of 5 is 32. And 1 times 2 power of 3 is 8. 1 times 2 power of 2 is 4. And 1 times 2 power of 0 is 1. So, ang magiging answer, yung mga answer sa tinimes mo na yun is pagpa-plus-plusin lang, and then ang lalabas is 173 subscript 10. So, binary to octal conversion can be converted by grouping the binary bit in group of 3 starting from LCB. Octal is a base 8 system and equal to 2 the power of 3, so a digit in octal is equal to 3 digit in binary system. So, dito, example kung paano makuha yung hexadecimal to binary to octal. So, hexadecimal number is E64B. So, dito sa una, expand each hex digit to 4 binary bit. So, yan. And then, next is, makukuha yung result in binary. So, next, i-group to into 3, and then, i-convert na hanggang sa makuha yung pinakang answer. So, binary to hexadecimal system, group the digits of the binary number by 4 starting from the right. Replace each group of 4 digits by an equivalent to hexadecimal digit.
Hi, I am Siren Estrellado and I am going to discuss the octal to binary conversion. Convert from octal to binary by converting each octal digit to 3-bit binary equivalent. Convert from binary to octal by group bits in 3 starting with the LSB, and each group is then converted to the octal equivalent. Leading to zeros can be added to the left side of the MSB to fill out the last group. So here, I am going to show you the table which we can use as guide to solve the octal to binary the hexadecimal to binary. To convert a hexadecimal to binary number, convert each hexadecimal digit to its 4-bit equivalent using the hexa number. For example, 23AB is equal to 0. Lastly, here are the list or the table of the hexadecimal number system. Dito like the binary, the decimal, the hexadecimal, the binary, the decimal, and the hexadecimal. That's all, and thank you.